titled Trigonometric Applications, and we're going to be answering the question, how can I use trigonometric ratios? So we're going to be looking at some real-world problems and using those trig ratios that we've learned. We're actually going to do page 20 first, so flip over to page 20. We're going to skip problem 91 at the top of page 20, but we're going to read our math notes box right now. So if you have a highlighter, go ahead and pull out your highlighter. And this math note is titled Inverse Trigonometry. So just as subtraction undoes addition and multiplication undoes division, the inverse trigonometric functions undo the trigonometric functions tangent, sine, and cosine. Specifically, inverse trigonometric functions are used to solve for the measure of an acute angle in a right triangle when a ratio of two sides is known. This is the inverse, or the opposite, of determining the trigonometric ratio from a known angle. The inverse trigonometric functions are used in this course are inverse sine, inverse cosine, and inverse tangent. Pronounced inverse sine, inverse cosine, and inverse tangent. Below is an example that shows how inverse cosine may be used to calculate a missing angle, and we'll call that angle theta. So they've marked angle theta right here. Go ahead and highlight it with your highlighter. From that angle, we have two side measurements. We have the 10, which is adjacent, and we have the 14, which is the hypotenuse. So the cosine function, the cosine is the one that uses adjacent over hypotenuse. So the adjacent is 10, that goes in the numerator. The hypotenuse is 13, that goes in the denominator. And then to type it in your calculator, you say inverse cosine of 10 over 15, hit the equal sign, and it's going to give you approximately 39.7. To evaluate the inverse cosine of 10 over 13, most calculators, you'll either have to hit the second button or the inverse button, just depends on what brand of calculator you have. You have to press that before you press cosine. If you're in Desmos, you have to go to the function tab and then find the inverse sine, inverse cosine, and inverse tangent. Okay? Any questions on that? All right, that's a good reference page if you're taking a test and you can't remember how to do something. All right, turn back over to page 19. Up at the top of page 19, we're going to start with question 89, which says, David and Emily are climbing El Capitan, a big cliff wall in Yosemite National Park. David is on the ground, holding the rope attached to a carabiner, which is a rope pulley that is on the wall, above Emily as she climbs. When Emily stops to rest, David wonders how high she has climbed. The rope is attached to his waist, about 3 feet off the ground, and he has let out 48 feet of rope, which goes up to the carabiner and then back down to the wall to Emily's harness. The rope at David's waist makes a 55-degree angle with the ground, and he is standing 20 feet away from the base of the wall. That's a lot of information. So we're going to draw a diagram of the situation. Okay? We can call this point D over here for David. He's standing over here, and he's 55 degrees looking up to the carabiner. Okay? And he's 20 feet from the base of the wall that Emily's climbing. Okay? But the carabiner, or the rope, is at his waist, right? It's here. It's not at the ground. So it's about 3 feet from the ground. You have to show the 3 feet right here, okay? Because it's not perfect with the ground, okay? Emily's somewhere along this wall on the rope, on the rock that she's climbing. So she's somewhere over here. We don't know how high she is. We're going to call that Y. And then we want to know how much of the rope is right here on the hypotenuse. Part A says, assuming that the rope is taut. Taut is just a word meaning that the rope is tight. It's not loose and like hanging down. It's pulled really tight from her weight. Okay. Approximately how long is the rope between David and the carabiner above Emily? Okay. So from this angle that I highlighted, we have this length, which is we're going to call, we're going to use this side of 20 feet, which is the adjacent. So I put adjacent right there. And the side we want to find out, which I labeled with an X, that's the hypotenuse. So the trig function that uses adjacent and hypotenuse is cosine. Okay? So we take the cosine of the angle given, set it equal to the adjacent, which is 20, over the hypotenuse, which is X. We make it into a proportion by putting it over 1. And then we do the cross product. So we're going to multiply X times the cosine of 55, set it equal to 1 times 20. And then to get the X by itself, we need to divide both sides by the cosine of 20. So it cancels on the left. And then on the right is what we're going to type into our calculator. 1 times 20 is 20. So we're going to take the 20 and we're going to divide by the cosine of 55. Hit the equal sign, and we get roughly or approximately 34.86. But next to that 6 is an 8, so we're going to round up. So we actually make it a 7.87. 34.87 feet. Okay? All right. Still looking at the same problem, it says, how high up the wall has Emily climbed? Okay, so now we need to know how high is she climbed right here, which is going to be this y amount, okay, which ends up being the opposite, and we already know the adjacent, so we're going to use tangent for part B, okay? You could have also used the Pythagorean theorem since it's a right triangle, but we're going to use tangent. We're going to say the tangent of 55 is equal to the opposite side, which is y, over the adjacent, which is 20. We've got that proportion, so we're going to do the cross product. 1 times y is y, and 20 times the tangent of 55 is, let's see, type it in the calculator, 20 times the tangent of 55 equals 28.56. There's a 2 next to it, so we stay. Got a weird glare on there. And it's roughly 28.56. Okay? We need to take that 28.56 and subtract it from the total rope length of 48. It told us back up in the original question that the total rope was 48 feet. That gives us 13.13 feet. So we need to subtract it from the 28.56. And then we have to add the 3 feet of how far off the ground that the rope started. Remember, it was at his waist, not at the ground. Okay? Which gives us a grand total of 18.43 feet. Gets a little complicated in there. Okay? Any questions on A or B? Okay, let's look at question number 90. Question number 90 says, the Bungling Brothers Circus is in town, and you are part of the crew that is setting up its enormous tent. The center pole that holds up the tent is 70 feet tall. To keep it upright, a support cable needs to be attached to the top of the pole so that the cable forms a 60-degree angle with the ground. Part A says, how long is the cable? Okay, so from the ground, the cable needs to go from here all the way up to here, and we need to know how long it is. So we're going to put an X there, but we do know that the pole going straight down is 70 feet. And we know that the angle is 60 degrees. So from that angle of 60 degrees, and let me highlight it, that angle, we've got the 70 feet, which is the opposite, and we've got the side we want to know, which is x. We'll call that hypotenuse. And so the trig function that uses opposite and hypotenuse is sine. So we're going to say the sine of 60 degrees equals the opposite, which has a 70, over the hypotenuse, which we don't know, so that's where we put our x. Okay? Make it into a fraction so that we have a proportion so that we can do the cross product and solve. Okay? So from the proportion, we go x times the sine of 60, set it equal to the 1 times 70. To get that x by itself, we have to divide both sides by the sine of 60 so that they cancel on the left, leaving us with just x. And then this is the side that we type into the calculator. So we're going to have 70 over the sine of 60. Now let me type that in the calculator for you. So it's 70 divided by the sine of 60. We get approximately 80.82, but there's a 9 next to that too, so we round up to 80.83. Okay? That's for part A. Okay? Then in part B, it says, how far from the pole should the cable be attached to the ground? That ends up being this side over here that I labeled with Y. That one's the adjacent side. So we know the opposite and we know the adjacent. Technically, we could use the hypotenuse now that we've solved for that, but I'm going to use the opposite and adjacent, which is tangent. So we're going to say the tangent of the 60-degree angle equals the opposite, which is 70, goes in the numerator, over the adjacent, the new side that we want to solve for, which is y. Oh, I called it x. I just prefer the variable x. And then I have my proportion by putting a 1 in the denominator. So we're going to multiply using the cross product. X times the tangent of 60 equals 1 times 70. Then we have to divide both sides by the tangent of 60, so they cancel on the left, leaving us with just the x. And then on the right, we have 70 divided by the tangent of 60. So here's what it looks like on the calculator. 70 divided by, this time, the tangent of 60. Oh, and it didn't give me a decimal. It gave me as a radical. Let me see. Okay. Well, as a decimal, it's 40.41. And it ends up being in feet. That's right. Okay. Any questions on part B as in boy? Okay. All right. You are